All right, now, now we can go ahead and think about some of these specific questions. So this one says, what size cut would produce the largest possible volume? So I'm trying to ask myself, where is the largest possible volume on my graph? And what size cut would produce it? Well, let's take a look over here. The largest possible volume is when the y value is the highest. And again, we said none of this portion of the graph makes any sense. So it's going to be here at this local maximum. And if I were to interpret that local max point, which was 1.21, 32.84, right? The x value is the size of the cut. The y value is the volume. So that tells us that a cut of 1.21 centimeters, right, would produce the largest volume. And the largest volume would be 32.84 centimeters squared. Centimeters cubed. I think I said centimeters squared before too. Centimeters cubed. Okay, so we found where the largest possible volume would be and what size cut would create that. Now, the next question asks us, what size cut would produce a volume of 15 centimeters? So I need to think about where that would be on my graph. And I actually think it's going to be really helpful for us to draw an equation, or to have our graph draw a second equation. So in y2, I'm going to set it equal to 15 so that I can take a look at where that would be and what size cut would create that. So I'm going to go back into my graphing calculator here. Here it is, same function that we were looking at before. And I'm going to go into y equals. And I have my original function still. I don't want to get rid of that. But in y2, I'm going to look at what happens if y is 15. Where would that be? And so that's actually going to give us an idea specifically about where we should be looking. So, taking a look at my graph here, if I draw this sketch in, looks like it's about right here. I'm just going to draw a sketch, right? So there's my line, y equals 15. And so there are actually two different size cuts that are going to create a volume of 15. So how am I going to figure out what those exact ordered pairs are? Well, my calculator can help me do that. So in my calculator, I'm going to go back into that calculate menu that we've been using. And right now, what I really want to find is that intersection point. Where does my line y equals 15 intersect with my function v of x? So the first thing it asks for is the first curve. So it just wants me to pick out where is my first function. So right now I'm on my polynomial. That's fine. I'm going to hit enter. Second curve, I want to just make sure I'm on the other function, which is my line. So I'm going to hit enter. And then guess tells it where to look. So I'm looking for the intersection that's about right there. And I'm going to hit enter. And it tells me 0.2945 ... comma y equals 15. So that tells me that if I make a cut of 0.29, I will get a volume of 15. So I'm going to go label that on my graph, right? 0.29, 15, that's one of my ordered pairs here. And that tells me that a cut of 0.29 centimeters would be one option, or, and I'm going to wait because I need to find my other option. So going back in, I need to repeat that process. I need to find the intersection now at this intersection. So I need to go back in to my calculate menu, I'm gonna go to intersect. I'm gonna make sure I'm on my first curve, so I'm on my polynomial right now, so I'm gonna hit enter. Now I need to make sure I'm on my line, which I am, so I'm gonna hit enter. And then guess, I'm gonna tell the calculator I want it to be looking for the intersection that's around here. And that tells me 2.399, which if I round to the nearest hundredth is 2.40. So I'm gonna go label that point right here on my graph again. That is at 2.40. And that tells me that a cut of 2.40 centimeters would also give me a volume of 15 centimeters cubed. Now, there is this third intersection point here, right? It's right here. However, this is not part of my feasible domain, right? So that part doesn't make sense. So I'm not going to spend my time on my calculator finding this ordered pair because it's clearly on this part of the function that doesn't make sense in the context of our situation. So we only have two spots that actually make sense. All right, now the very last part says determine volume when x is 2.5. So first of all, think about what this is saying. We're going to substitute 2.5 for x. So that means that we are going to make a cut of 2.5 centimeters, and we're going to find out what is the volume. So on our graphing calculator here, I'm going to go ahead and I'm going to use another feature in this calculate menu. So I'm going to go back in, second calculate, and what I would like to find is the value. So when x is 2.5, what is y? So I'm going to hit enter on value, and notice it gives me an opportunity to say, okay, what value of x do you want to find the value for y? So I want to find y when x is 2.5. So I'm going to type 2.5. Notice how it also shows me where that is on my graph, and it tells me that the y value would be 12.5. So in here I can say that the volume of 2.5 is equal to 12.5. This is really like giving us an ordered pair, right? That says when x is 2.5, y is 12.5, which means that if we cut of 2.5 centimeters, the volume of the box will be 12.5 centimeters cubed. And that's what that tells us. So we're using the value function of our calculator to help us with that. All right, that is all. Go ahead and give example 3 a try.